Welcome back, learners, to the second part of this question. Now, we finished when we talked about the reagent that was in excess, which was zinc. So when you go to the part B of this question, you are now asked, calculate the total volume of hydrogen gas liberated at STP. STP means standard temperature and pressure conditions. And then you've been given, already we used the RFM of zinc, but we've not used this molar gas volume, which is 22.4 liters at STP. So you are expected to get the volume of hydrogen gas at STP. So this question, you have to be very careful when you are dealing with it. You have to come back to this question and you look hydrogen. You see, if you look at hydrogen, the mole ratio of zinc is 1 at this point. The mole ratio of zinc is 1. The mole ratio of hydrogen is also 1. So that means zinc and hydrogen, they have equal number of moles. In short, they have equal number of moles. Zinc and hydrogen have equal number of moles. So that will bring us to here. What was the moles of zinc? The moles of zinc was 0.0299 moles. That is the same moles that hydrogen is also going to have. Naelewana hapo vizuri? So we'll have to talk about the mole ratio. We talk about mole ratio of hydrogen gas. The mole ratio of, let me write it again in small letters, mole ratio of hydrogen gas to oxygen gas is 1:1. This is 1:1, okay? 1:1, okay? So that means hydrogen to zinc, not oxygen. This should be hydrogen to zinc is 1:1. So that means since hydrogen was having zinc was having 0.0299 moles, hydrogen is also going to have the same number of moles. So that means hydrogen will also have 0.0299 moles. Okay. So because we've been given the molar gas volume, which is 1 liter, remember the molar gas volume is usually equivalent to 1 mole. Molar gas volume is usually equivalent to 1 mole. So this will mean that this molar gas volume, which is 22.4 liters, will be equivalent to 1 mole. So you'll ask yourself, if 22.4 liters is equivalent to 1 mole, what about the number of moles of hydrogen, which is now, I'll come and note it here, what about 0.0299 moles? So once you reach there, what you'll simply do is to cross multiply this with this, and then now you're going to get your number of moles, your total volume. If you calculate that, you'll get your total volume will be 0.6, your total volume is going to be 0.6713 liters, which if you convert into cubic centimeters, it will be 673.1 centimeters cubic. That will now be your answer. Okay. Then you go to this question 2, where you are now asked, calculate the mass of carbon nitrogen dioxide gas that will occupy the same volume as 10 grams of hydrogen gas at the same temperature and pressure. So if you're told 10 grams of hydrogen gas, remember we've been told here hydrogen is 1, nitrogen is 14, oxygen is 16. These informations are all very important. So you're told hydrogen is 1. You know hydrogen, if you're writing hydrogen Hydrogen, I know most of you learners usually write it as H. When it is a gas, it has a 2 hapa chini. So that means hydrogen exists as a diatomic molecule. Because there are 2, and you already know that we have hydrogen is 1, so that means the RFM of hydrogen will be 1 plus 1. So that means your total RFM for hydrogen will be 2. So that means 2 grams of hydrogen is the one that produces 1 mole. Okay? 2 grams of hydrogen produces 1 mole of the hydrogen gas. So you'll ask yourself, if 2 grams is producing 1 mole, what about 10 grams? This 10 grams here. So you say, come and say, what about 10 grams? Will give you how many moles? That is the question that you'll now be asking yourself. So you know when you reach there, it's very simple. You just cross multiply, and you'll get that the moles of hydrogen gas that you'll produce in this case, they'll be 5 moles. 5 moles of hydrogen gas. And remember, you've been told to calculate the mass of nitrogen oxide gas occupying the same volume as 10 grams. That means the number of moles are still going to be the same. That means nitrogen oxide gas pia itakuwa na 5 moles. Tunaelewana hapo? Now, you now ask yourself, if nitrogen oxide gas is also going to have 5 moles, remember you have to know how to write nitrogen oxide gas. Nitrogen oxide gas is written as NO2. And if you get the RFM of nitrogen oxide gas, nitrogen is 14 and oxygens are 2. So that is 16 times 2. So for you to get the RFM of nitrogen oxide gas, you'll have 14 plus 16 plus 16. The major reason I'm adding 2 16s is because oxygens are 2. Okay? So that 16, I want to add this. So that 16, I'm having 14, which stands for nitrogen, and 16 and 16. So if I add 14 plus 16, I'll have 30. And then 30 plus 16, I'll have 46. So that means our total RFM there is going to be 46. So I'll say, because my total RFM is 46, and remember, this 46 is the one that produces 1 mole of nitrogen oxide gas. So you say, if 46 grams is produced by 1 mole of NO2, which is nitrogen oxide gas. So you say, what about the 5 moles that we formed here? What about 5 moles? So when you reach there, I simply say, you do something which is very simple, just cross multiply. And when you cross multiply, you're going to get the total mass of nitrogen oxide gas that will be occupied at that point, which will be 230 grams. 230 grams. I hope you have also enjoyed this session, learners, and I hope you are learning something special with our channel. Thank you very much. God bless you. Kindly subscribe, share, like, and you can also talk to your friends from other schools to also come and view the good work that you're doing here. Thank you.